Hey, so in my recent Monday class, I have an AME class and AIME prep, and sometimes we'll do final five problems from AMC 12. And so this last Monday, we went through this problem and I really enjoyed the process. And so I thought I'd go over it with you. So let ABCD be a parallelogram with area 15. We're probably going to need that. Points P and Q are the projections of A and C respectively onto line BD. We note them quickly and go back to reading. And points R and S are the projections of B and D here, onto line AC. See the figure which also shows the relative locations of these points. Now, from the picture, you see that P and Q are 90-degree angles. From that, you can infer that all projections will be 90-degree angles, and that's actually a true thing as well. So suppose PQ is 6, even if you didn't know though, like if you didn't know about projections, you could draw the inference based on the other two that it must be making 90 degrees. So PQ is 6. Here's the thing, this diagonal meeting point of the original parallelogram, I'm going to call it M. That point is the midpoint of both diagonals. In other words, the diagonals of a parallelogram bisect each other. That is a small notebook concept. You might want to write it down. Now what we might wonder is PM equal to MQ? And so to do that, we'll probably have to prove some triangles congruent. How can we do that? AP and CQ are heights of two congruent triangles. When you cut a parallelogram in half, namely like this, that triangle is equal to the other triangle. And since they're both equal in area and the same base, BD is their base, then their heights must be the same since they have the same area as well. So I'm going to go back and clear this off, actually the whole thing, and relabel the M. So we would know that AP is congruent to CQ. You have a right angle, and you have vertical angles. So by angle side congruence, we know those are equal. We also could have used that AM is equal to CM and various other ways. But what we do know is that PM is equal to MQ as a result of the congruent triangles. So then that makes PM3 and MQ3. Now RS is 8, but that doesn't tell us what MC is, the hypotenuse of triangle MCQ. I'm going to call it X. We may at some point in the future say that CR is 4 minus X, or half of the 8. And you say, well, wait a minute. We know that AM equals MC. How do we know CR is equal to AS? Noting these are right angles over here, you can do the same thing. You would know that DS, which would be a height of the triangle that I'm going to trace right here. So a height of this triangle, the height being external to the triangle is fine, and BR is a height of a congruent triangle. So again, those two heights have to be equal for the same reason as the others. Once you have that, you have DS. You also have that opposite sides of a parallelogram are congruent. So then by HL, the congruence for right triangles, you do have that the triangles are congruent. Never assume anything on the AMC. If you think something is true, justify it. Otherwise, you're just making an assumption. Okay, and assumptions can get you in trouble. So make sure you establish those things. They distinctively take advantage by placing good-looking assumptions in problems just to trick the students. So if you're not being careful, you're going to get tricked if you have not had that experience yet. Okay, continuing on. We know then that MR is equal to MS because AS would be equal to CR and forces that. Okay, but again, we don't know that we're going to need that 4 minus R. I just wanted to point out how you would establish that. The longer diagonal of ABCD is D. Let D denote what BD is. So I'm going to stop for a second again and look at BD. We're asked to find D squared. And when they say this, when they say can be written in the form, I just stop reading. At that point, you need to get to the place where you know what D squared is, and then you worry about what form it is. You might glance at what form they wrote. You're looking for D squared. Maybe we're going to use, who knows? We'll just try to look for this form to appear at the end, but don't worry about sometimes they'll say something like where p is not divisible by the square of any integer or any prime or something like that. That's all simplification stuff, and you can inspect that at the end. Focus on the problem at hand because those are the thoughts that you're thinking about. Don't think about the end game right now in your problem solving process. That goes for all problems that say can be written in the form. Just find it first, then worry about its form. Okay? Or at least have an idea of how you will find it. Okay, so now what? We look back. I need to find d squared. They told us this area was 15. So if you look at BD, it is the base of triangle DCB, which means that is half of 15 if I find the area. So why don't we write that 1/2 of the diagonal D, which is what we're looking for, D squared really, but 1/2 of that diagonal times CQ, which is the height, is going to equal 15 over 2. Now what we can do is cancel the 2's. Basically multiply by 2 on both sides, and we get ourselves to this point. I would consider this a significant conclusion. I've reached the end of its thread. There's nothing else you can do with that right now. And go back and look. If we could get CQ in terms of D, then we'd have a system that we could possibly solve for D or D squared. We're more likely to find D squared, though, as our goal. We don't want to find D if we don't have to, because D squared would be the final thing you're looking for. So how are we going to do that? We do note that CQ, by Pythagorean theorem, is the square root of x squared minus 9. This is, by the way, the 2021 spring test. I guess I forgot to mention that. So you have this square root. What I would need then is x in terms of d. And because of that, I don't know about you, but I'm looking at the fact I've got a right angle and a right angle, and this angle M is in both MRB and MCQ. So I'm going to make a similarity statement. My advice is to make your proportional statements from similar triangles based on a similarity statement, not on a picture. A picture, you're more likely to make a mistake, and it could be not to scale. So I'm going to say MCQ is similar to, and it's going to be M first because they're the exact same M in both triangles. Now I look at the 90-degree angle, which is Q, and it's in the third position, which means R needs to be in our third position, and it is B that goes in the middle. If you do it like that and you're careful, the next part is flawless. You can't get it wrong. It's just the relative positions or corresponding side lengths. For example, the first two letters to the first two is MC over MB. And that's going to equal CQ over BR. I don't want to write either one of those, even though we can represent CQ in terms of X. But let's look at MQ, which is 3, MQ, first and third, and MR, first and third, which is 4. So I should have probably written the letters first and then converted. MC we said is X, and MB is half of that diagonal, so it's D over 2. So now it looks like this. You're going to just go ahead and immediately cross multiply, mostly because it will look better. And you want X in terms of D. So if you had found this before you got this mini conclusion over here, you would probably still instinctively multiply by D over 2, and you're going to get 3D over 8. Next, we're going to drop that 3D over 8 into the X and square it at the same time. So I'm going to do it on the other side of the screen. We have D times the square root, and you're squaring the x squared, which would be 9d squared over 64, and then it's minus 9, and that's equal to 15. Now, if you're going to be doing problem 24 on an AMC 12, you've got to have pretty good assessment of what things come next. For example, both of my terms inside the square root have a 9. I'm going to factor the 9 out in my mind. I'm going to know it becomes a 3, and I'm going to divide it into here to get 5 on my next step while not really doing anything. D squared over 64 minus 1. So I'm not going to change too much. I'm just going to eliminate the 9 and the 15 at the same time and lower the 15 down to a 5. So now we're going to square both sides. So you're going to square the D, and you get D squared. You're going to square the square root, and you're going to get what's inside, which is D squared over 64 minus 1, and you're going to square 5 to get 25. At this point, I will multiply by 64. Now, since this is all a product, I don't have to multiply this. It's just the parenthesis I'm going to multiply by 64. So when I do that, it's going to now say d squared times d squared minus 64 equals 25 times 64. Realistically, this would have been on both sides. Maybe I could put parentheses here, even though it's illegal because of the equal sign. We just disregard that for a second. Okay, so now I'm going to here's something else that I do a lot. If I want d squared, you're looking at it right now. Um, Very interesting. I almost want to guess what we're doing. We want to multiply two things that give 25 times 64. I bet you could do this. I might try it right now, but I'm doing this in a recording, so I don't know. I didn't do this during my class. Let u equal d squared. Okay, if you find u, you find the answer. At this point, I almost just want to guess what the two numbers might be. You're looking for a number and a number that, oh, you know what? We're not going to find it. You know why? You can tell from the answer. D squared's not a nice looking thing. You're not going to get a factorization. That right there is what would preclude you from attempting that. But otherwise, sometimes I like to go for quick solves on that and just guess what the numbers might be. But you're definitely not going to find them. So let's go ahead and continue. You're going to get u squared minus 64u minus 25 times 64 equals 0. I tend to leave things as products. I don't care that it's 1600. That's irrelevant to me. I would just leave it like this because it gives you more options. I am going to erase the right side of my screen so that I can create more space to solve in and continue on. So now we're just going to do what? Quadratic formula or completing the square. It's your choice. But you have to know, like, you're at the finish line. You need to be quick with your calculations. You've done all the hard part, which is coming up with the plan. And it really isn't that bad. When you're looking at two right angles right here, to me, right away, the fact that like I see a right triangle here, and I look for the other right triangle, and I go, wait, they both use M. That just screams at you similar triangles, in my opinion. So now we're going to go over here. We got negative b, which is 64. And it's plus or minus, but you're only going to write plus because our answer only has a plus. So we don't even care if there was a viable minus answer. It's irrelevant. 64 plus the square root of b squared, which is 64 squared, minus 4 times a, which is 1, your coefficient of u squared. Your c is negative. So what I'm going to do is change this to plus and put plus 25 times 64. Again, leaving things factored is to your benefit. It doesn't matter if you can calculate quick if it would have been quicker if you didn't. So don't calculate until you have to. Keep things as factors just like this. So now it's a key tactic for speed on the concept, which is really important. Okay, so now you've got a 64 and a 64 here. I'm going to factor them out. There's a denominator, by the way, the 2a. I'm just not writing it right now because I'm focused on the numerator, but I'm aware of its existence. So I'm going to go 64. Now, when I factor out a 64, I'm not going to write the parentheses like this, 64 times 64. Why am I not going to write this? Because that's what you do for your school teachers. And we don't need to show this to our school teachers. I can see in my mind there's a 64 and it's going to become an 8 on the outside of the square root. So we can go 8 square root and now write that part. And even as I'm doing it, I'm probably going to write the 64 as 4 times 16 plus 4 times 25. And now I'm going to write 64 plus 16 root 41. And now I'm going to put the 2a, which is 2. That's a 1 right there. So I anticipate the next move, and I'm looking ahead in the process. So I know I'm going to have a 64 left, but I'm glancing here and as I'm factoring, because you don't want to stand still while you're doing it all in your head, but you can still grease the skids a little bit so that your next steps are a little bit smoother. So when you get to here, there's less chance of an error if I write that 64 as a product of 4 and 16. Always be kind of thinking ahead while you're calculating is my recommendation. If you're not good at that, practice it more in problems. You'll get better at it. So now divide the 2 in and you get 32 plus 8 root 41. That's 40. That's 41. It's asking for the sum of these. That's 81. Now, right now is when you do a quick pause and read that ending. Can be written in this form where m, n, and p are positive integers and p is not divisible by the square of any prime. We're used to that statement. We anticipate it. seasoned veterans don't have to read this part. You understand what it says. So try to get that down as well, that a lot of questions end with that, and there's really no point in reading it, okay, until the very end. So now it is, what is the sum of m plus n plus p? And so we've got all those here. It is 81, and that's the answer. If you're interested in classes, do reach out. I have a lot of class options right now for AMC 10 and AMC 12. I have a AMC fundamentals class that goes through volume 1. I have a class of AOPS textbook, and I have an AMC fundamentals 2 that goes through the volume 2 textbook of their materials. So reach out if you have any questions. It's on my website. The link will be down below in the description. I hope you guys are preparing well for this year's AMC, and I'll see you